Hello everybody, this is Dr. May and we're going to continue our exploration of the organization of the periodic table. We've already seen that elements are arranged in their rows and columns from increasing atomic number, going from 1 to 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., going from 1 all the way down to 110. Increasing atomic number also means increasing number of protons. And now we're going to look at how they're arranged in columns. There's some significant importance to that arrangement as well. As you're following along, you should be taking your notes on the periodic table of elements notes page that looks like this. We're going to fill this in and get some color added to this to help us organize these elements based on their groups. So this organization scheme we call families or groups. Elements on the periodic table can be grouped into families based on their chemical properties. These groups are these columns, as you can see. Now we're going to look at 8 different groups. And each group has a specific name and a specific number. The number actually holds more importance, as it will tell us something useful about the atom. And then elements in each family react differently with other elements. So elements in each column have very similar chemical properties with respect to each other, but different chemical properties with respect to elements in a different group. All right, at this point we should be able to fill in this top section of our periodic table notes. I'll go ahead and do that now. All right, now that I have those blanks filled in, let us continue on to our first group. We'll actually be looking here at, starting from the left, looking at this first group here. We're going to work our way from left to right. Our first group, group 1, is its number. Alkali metals is its name. This name is very commonly used for group 1 metals. Note that hydrogen is not a member. What we want to first do is take a look at these Bohr model representations of each atom. We've seen these before. So lithium, as we'd expect, 2 electrons in the inner ring, 1 on the outer, for a total of 3. As we move down, sodium's got 2 inside, 8 in the middle, and 1 on the outside. Potassium, note there's 1 on the outside. Rubidium, 1 on the outside, etc. as we go down. The group number is actually telling us how many electrons exist in the outer ring. We're going to eventually call these valence electrons, and they are supercritical to the behavior, the chemical behavior of an atom. And so it is the fact that they all have 1 electron in their outer orbital, or their outer shell, that gives them very similar chemical properties. In this case, they're all very reactive, especially with water. All right, at this point, we can go ahead and fill in our periodic table notes. I'm going to add a little bit of color here to the first group. Note that I'm excluding hydrogen. It is not considered a group 1 metal. Get that filled in. All right, and at this point, we're going to now take a look at the reactivity of group 1 metals. This video is going to show you sodium being dumped into a lake, sodium being added to water. Enjoy.
Look at that.
All right, our next group, group 2, also has a very commonly used name, and that is alkaline earth metals. Group 2 meaning they have 2 electrons in their outer shell. They're reactive, but less so than alkali metals. They're white and malleable, kind of like silly putty. They're fairly soft metals, so you can bend and shape them somewhat easily. All right, let's add this now to our periodic table notes. I'll go ahead and add a splash of color here. All of the elements in this column are group 2. All right, at this point, we're going to take a look at a video of magnesium being lit on fire. We've seen. How's exposure?
Good. These are good.
Alright, as we march across, we encounter this big block in the middle. We're not going to spend too much time here, but it is important to know what they're called. This entire block we're just going to refer to as the transition metals. They are very good conductors of heat and electricity, so you'll see platinum, you'll see gold in this group used in electronic devices. Gold and silver and copper in here, the coinage metals, so they're used for jewelry and coins because of their nice shiny luster properties. These guys can hold a lot of electrons, up to 32 in their second to last shell. And this means that they can bond with many elements in a variety of shapes. So they form some pretty cool compounds. They form, when in solution, they form really cool colors like blues and greens, teals and turquoise. So they've got some very interesting chemical properties. We're not going to spend too much time on them right now. But that doesn't mean we won't make mention of them on our periodic table notes. So we'll go ahead and label this whole middle section here, the transition metals. And we can add a nice big splash of color here. Alright, there we go. Alright, now we've got group 3, moving towards the right side of the periodic table. This is sometimes called the boron family. That name isn't used all that common. But group 3 is certainly what we want to refer to it as. It tells us that there are 3 electrons in the outer shell. Most of these are metals. Boron is a metalloid, and we'll talk a little bit more about what that means coming up. But at this point, let's go ahead and fill in our table. And I'll go ahead and color in this column here, our boron family. So I've said this one before. Group number is number of valence electrons, so let's go ahead and write that in up there. So the group number is the number of valence electrons. Valence is going to mean outer shell electrons. And it is those outer shell electrons that give rise to the chemical properties of an atom, which is why elements in a column react very similarly, because they all have the same number of valence electrons. Sure, they're going to be in a further out shell, but they still only have, in this case, 3 valence electrons.
So here we have one of those aluminium heat sinks that you find inside your computer. Now if you have ever felt one of these, you'll know that they're pretty tough and very hard to break. First of all, I scratched an indent into the aluminium so that the gallium will access it easier. Okay, just need to melt some gallium on there. There we go. Oh, it. I'll just try again. Oh! Finally! Once I had the gallium on there, I left the whole thing for around 8 hours. Now let's see what the gallium has done to the heat tray. It looks a bit... whoa. It's incredibly brittle. In fact, I think I could snap it in half. The gallium has diffused with the aluminium and just totally weakened the structure. Amazing. So there we have it. Gallium.
Alright, our group 4 contains carbon at the top, hence it gets the name carbon family, but again, not very commonly used. Group 4s have 4 electrons in their outer shell, or that is to say 4 valence electrons. And as we're going to see, contains metals, metalloids, and the nonmetal carbon. We're going to actually divide up our periodic table in a little bit to show you how those differentiate themselves. Alright, let's fill in our periodic table notes and add some color here. Alright. Group 5 contains nitrogen at the top, so it gets the nitrogen family name, also not a commonly used name. Group 5 has 5 electrons in its outer shell, and these guys can share electrons to form compounds. When we talk about bonding of atoms to form molecules or compounds, it's going to be important that we know what sides of the periodic table elements come from, what groups they come from. That's going to actually help guide our construction of molecules. And again, this group contains metals, metalloids, and nonmetals. Let's fill in our table and add in a little bit of color. Group 6 has 6 electrons in its outer shell. Carbon is the leader of this group, and oxygen is the leader of this group. And so we'll refer to this as the oxygen family, also not commonly used. But 6 electrons in the outer shell, again containing metals, metalloids, and nonmetals. These guys tend to be very reactive. So let us fill in our periodic table and add a little bit of color. My little electronic device that I'm using right now only has 6 highlight colors available, so I'm going to reuse one. But don't think this to mean that group 6 is in any way similar to group 1. Alright, now we get to group 7, meaning 7 electrons in the outer shell. This group has a very, very commonly used name, and that is halogens. Group 7, fluorine, chlorine, bromine, iodine, are referred to as halogens. They are all nonmetals, and they are all very reactive, and often bond with elements from group 1. Let's fill in our periodic table. Alright, again I'm going to have to reuse a color here. Got yellow going on. Again, group 7 is not related to transition metals, so don't think that color means anything. At this point, we've got a video to look at for iodine. At room temperature, iodine is in a solid form. It likes to form these shiny crystals. When you heat it, it goes directly from the solid to the gas phase. It does not form a liquid. We call that process sublimation, and you'll see that now.
So this is iodine, and this is in solid form, solid iodine, and it's small silvery crystals. Okay, so if I take a little scoop of this, see it looks metallic, but it's actually a non-metal. Okay. And interesting thing about iodine is that it sublimes. It'll go directly from a solid to a gas and skip right over the liquid phase. So, we're going to heat this up with Bunsen burner. And so it's gonna sublime to a gas. You'll see it inside the beaker as a gas, and then it's gonna hit the cold porcelain of the evaporating dish, which is full of ice right now, and then it'll deposit and actually grow those silvery crystals right back. So it's gonna go from a solid to a gas, and then a gas back to a solid. So I'll turn on the gas. So a little piece escaped and went onto the wire mesh there, and you can see a little bit of purple smoke immediately as that burned. We're doing this inside of the hood because iodine crystals can solidify back inside your lungs if you got a good whiff of this purple gas, and that could be kind of dangerous. Okay, so we'll release the poison vapors.
poison.
See the purple haze coming out of there.
Nicely done.
Don't it?
Die from iodine crystal.
And our last group in the main part of the table at the top, Group 8. These guys have a very common name as well, the noble gases. They exist as gases, as their name suggests. They are all nonmetals, and they all have 8 electrons in their outer shell. We're going to refer to this as being full when we talk a little bit more about valence electrons. Helium, though, at the top only actually has 2 electrons in its outer shell. That makes it full as well. Think of them as being noble. They're very non-reactive with other species. They're kind of like royalty. They don't want to interact with anybody else. They think they're too good for the rest. So they basically do nothing. They hang out here in their 8th column with their full outer shells and just sort of leave everybody alone. And now let's fill in our periodic table. All right, I'm going to again reuse a color here. But again, these are not to be confused with Group 2. They are their own group. And the last one we'll make a quick mention of, but we'll spend no time with in this class, are the rare earth metals. Some of these are radioactive. We've got plutonium and uranium down in this group. They are silver, silvery white, or gray metal. They conduct electricity. Some of them only exist in laboratories because they are created and exist for split seconds. Some of them have other uses, though. So rare earth metals. All right, let's add those into our periodic table notes right here. So we've got our rare earth metals. Now let's take a look at these blanks down here. I want to go ahead and classify something we've been mentioning, and that is our metals, nonmetals, and metalloids. If you'll see, there's this staircase here, starting with boron, working its way down the right half of the periodic table. This staircase separates the metals from the nonmetals, and elements along this staircase are called metalloids. So let us fill those blanks in now. All right, so we've got our metals on the left, our nonmetals on the right, and our metalloids are along the staircase here. All right, and that wraps up this lesson about the groups or families of the periodic table. The more important thing to take away are the numbers, as they indicate number of valence electrons in a given column. But the 4 names we want to keep familiar with are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. But otherwise, this is the big thing we want to take away. The group number is the number of valence electrons.